Hello everyone, welcome back. Welcome back to another exciting video. HTTP, WebSocket, SSE, WebRTC. If you are preparing for a system design interview, then you might heard of all these terms. But instead of memorizing what each does, first let's understand why each protocol is really required, why it exists. So in this video, we'll start with the problem statement first, and then you'll see how each protocol actually solving that problem. Let's start with the basic one. I have two computers, and suppose one computer wants to send some bytes to other. So now what actually carries those bytes from one machine to other? So here is something where TCP/IP network stacks comes in. So in this network stack, we have multiple layers. IP layer is actually responsible for routing the packets across multiple machines. TCP layer provides a reliable and ordered packet delivery. And at top of these two layers, we have application layer where we have all other protocols like HTTP, etc. So we as an application developer, we do not much care about how the packets got actually transmitted. We majorly build application on top of this network stack, right? But this TCP/IP networking stack gives us the foundation for communication between multiple machines. Great. So our computers can now communicate, but still there is a problem. What if someone is listening on the network? For example, if I'm doing any banking transaction by using my password or the credit card number, obviously I do not want that someone can read or modify this data. So this is where TLS comes in. So TLS basically encrypts the communication between client and server and provides extra security over the data which is transmitted. So when we use HTTP plus TLS, then we called combined as HTTPs. So HTTP is nothing but HTTP with TLS. So now let's move one level higher. Suppose I open an e-commerce website, then my browser needs a product page from the server. And how does browser ask for it and how does server answer? This is where HTTP comes in. HTTP defines a standard request and response model for the communication. In this example, client is requesting for the products, and then server process the request and then respond with some data, right? So HTTP is a contract between client and the server. It defines a process that how to interpret the request, how to interpret the message. It is not responsible for sending the data from point A to point B. That is handled by the TCP/IP only. But HTTP defines a way to read the data, right? For example, here I showed a sample HTTP request. So it follows a particular pattern. So the first line always contains a method, a URL, and the protocol version. Then we have some headers, and then body is optional. So every HTTP request will follow this pattern, so that server will be able to interpret it, that what resource is actually requested. And HTTP is stateless protocol. That means every request is treated as an independent request, and server does not automatically knows what was the previous request. So in your application, if you want to store user information, then there are other mechanisms to handle it, like sessions, tokens, and cookies. But HTTP does not remember the previous request. So HTTP has solved our communication problem. But imagine we are building a large application with hundreds of APIs. Then how to design this? Should we create these APIs like this, get product, create products, or fetch product by ID? Or should we follow some consistent structure? So this is the place where REST comes in. REST gives us an architectural style for designing APIs around resources. For example, if you want to design all the products related APIs, then like instead of mentioning the verb in the URL, for example, get, create, or fetch, we can use the HTTP method as a verb, which will tell us what to do, and the resource name in the URL. So for example, if the HTTP method is get, that means we need to fetch or we need to get a particular product. If it is post, that means we need to insert it into the DB. If it is put, that means we'll update it. And if it is delete, then particular resource will be deleted. One more important thing, REST is not replacing HTTP. Instead, REST works on top of HTTP because REST is just an architectural style. It is not a protocol. Okay. So now imagine a mobile application is showing user's profile. User's profile contains multiple data like his name, user profile picture, his friends, or his last activity. So this is a lot of data. So there are two ways to handle it. Either we can create multiple APIs, and then client can request all the APIs parallelly and get the data. And other option is that we can create a single API which render all the data in one go. So in both the cases, either we are doing underfetching because we are calling multiple APIs parallelly, and each API is returning a small amount of data. Or in the other case where we were using a single API, we are returning a lot of data, but suppose client only needs one or two fields from the data, right? So this is case of overfetching. So to resolve it, the question comes: what if client only tells the server that what data it exactly needs? That is the idea behind GraphQL. So in GraphQL, client will send a query object that contains all the fields which are required, and then server will only send all the fields which are mentioned in the query. So in this way, GraphQL can handle both the things, underfetching and overfetching. And similarly, it is not a separate protocol. It runs over HTTP only. Till now, all the protocols that we discussed, in every protocol, client was a triggering point. Client was always starting the request, and then server was responding. But let's look at a different example. Suppose we need to build a stock broker application where stock price would be visible on the screen, and stock price will be updated in some time period, after 1 second or after 5 seconds. So to handle this, there are multiple approaches. The one which is simplest one, which is polling. In polling, client will send a periodic request to server. So irrespective of data is updated or not, client will send the request. So in this approach, there can be multiple requests which are actually unnecessary because there is no change in the data. The other one is long polling. In long polling, client will send the request to server, and server will not immediately respond. Rather, server will wait for the data to update. Whenever the data is updated, then only server will change. Until that time, server will wait for the updation. So the best way to handle these kind of cases is SSE. SSE stands for server sent events. So here we are not closing the connection between client and the server. Connection will remain open, and then server will send the update to client whenever there is some change in the data. So it is unidirectional communication. The data will always be flow from server to client. Okay. It is quite different from the WebSockets. In WebSockets, client and server both can send the data to each other, but in SSE events, only server can send data to client. So now think about a chat application where client can send message at any time, but the server can also receive message from another user, and then immediately it send it to the client. So both side can communicate at any point of time whenever they want. So this is where WebSocket comes in. WebSockets provide a persistent bidirectional connection. Once the connection is established, both sides can send the message whenever they need to. So in this diagram, you can see here also the connection starts with a HTTP handshake, but later it is converted to a WebSocket connection. Whenever we need a persistent bidirectional low latency connection, then we can use WebSockets. For example, chat application, gaming applications, or some application where we need a real-time data. So in all these cases, WebSocket can be useful, but it is not something which you can use always, right? For login, you still use HTTP. To show the profile or any web requests, still HTTP is the best. But for message sending, message receiving, all these things, WebSocket might be a good choice over HTTP. Now let's move one step further. Suppose we want to build a video calling application. So we need to continuously send audio or video signals between two clients. Can we use WebSockets here? WebSockets can create a bidirectional connection and send the data. But when it comes to audio and video signals and all, then there are additional requirement as well. For example, very low latency, handling packet loss, adapting to the changing in the network, right? So to handle these kind of situations, we need a specially designed protocol that can handle all these requirement for audio and video. And this is where WebRTC comes in. So in WebRTC, what happens? First, client A and client B. Here in this diagram, you can see both share their communication information, their connection information with each other. And then once a particular connection is established, then both client A and client B can send the audio and video signals in peer-to-peer manner directly to them. So there is no server in between once the connection is established. This is different from the WebSocket. In the WebSocket, there is always a server which is in between. But in WebRTC, once a connection is established, there is no server required. So now we discussed all the technologies in protocol. Let's quickly connect everything. If two machines need to communicate with each other, then we have TCP/IP network stack. If we need a secure communication, then TLS or HTTPS. If client wants a simple request response from server, then HTTP protocol. If we need a consistent API design, then we can go with the REST. If client needs flexible data from server, then GraphQL is the right choice. If server wants to send or wants to push some data to client periodically, then server sent events SSE would be the right choice. If server and client both side need a real-time messaging, then WebSocket can be a useful choice. And if two client wants to send audio or video data with each other, then we can use WebRTC protocol. That's all for today's video. If you really liked it, please subscribe the channel. Thank you for watching. We'll see you in the next one.